Hello, today we're going to be looking at part 2 of the chromatography of soy sauce. So in the first part we looked at paper chromatography of soy sauce and amino acids. In the second part we're going to look at thin layer chromatography of soy sauce. So instead of using a piece of chromatography paper, we're going to be using a TLC plate. Okay, or thin layer chromatography plate, which in this case is a sheet of plastic, okay, which has had a very smooth and even paste applied to it and allowed to dry. So it has a very fine, even surface with which the material can travel. It's much finer than that of chromatography paper, which will allow a much greater separation of particles than chromatography paper. It is very fragile and very delicate. Now, chromatography plates should only be handled by the edges, okay? And you'll see today I'm wearing gloves. The reason I'm wearing gloves today is that we are doing an amino acid test on here. And you may not be aware of this, but amino acids are present in your fingerprints. So if you get the amino acids off your finger onto this plate today, at the end of it, when we develop it with the ninhydrin spray, you will actually get fingerprints which will interfere with your results. So we're wearing gloves today. So like we did with the paper chromatography, the first thing we're going to do is we're going to very carefully and very lightly, you must do this very, very gently, we're going to mark 10 mil or 1 centimetre up from the bottom and draw a very faint line across the bottom of our plates. Now we're going to need to use 2 plates today. Okay, we're going to use one to run our 2 different soy sauce samples and one to run our amino acids, simply because we need to allow space between the samples for them to run, and if we were to run them all on the same plate, they would be too close together and likely to interfere with each other. Now you must be very, very gentle. You're only talking the lightest, sketchiest line across. If you press too hard, what will happen is that the pencil will actually dig in to the material on the top of the plate and create a groove in it, which will actually stop or affect how the materials run up the plate. So we've got 3 amino acids we're going to run again, which are aspartic acid, glutamic acid and leucine. So on one of the plates we're going to need to mark 3. Okay, so these plates are 5 wide, so we can do them put one at 10 mil, one at 20 mil and one at 30 mil, so that's fine. So that we've got evenly spaced, so there's sufficient space between them that they hopefully when they run they will not cross into each other, and that when we're spotting on them that they will not run into each other. If they're too close together, when we're putting the spots of solution on, they'll overlap and then you'll get contamination, you won't get the clear bands. And then on the other one we've only got 2 to do with the soy sauces, we've got light and dark, so we could quite happily do them a reasonable distance apart. And all we're doing is just making a faint pencil marking where we're going to do it, and then we're going to label it. So I'm going to label it as an L and a D, and in this case we've got an A, a G and an L. Now what we're going to do once we've done that, and as you can see we've got 2 little marks on the line, and then we've got 2 little marks on the line and then our letter. So what we're going to then do is we've pre-done our soy sauces already, because we needed to make them up for the paper chromatography. So these are a 1 in 10 dilution, because if we do it as a straight soy sauce it's too thick and gloopy and syrup-like. We're going to use a capillary tube. We're putting our capillary tube in, finger on the top to stop it running out, and then we're just gently spotting on. Okay? And we do the same with the light. We're going to need to do this at least 5 times, allowing it to dry in between. Okay? we need the sample to be reasonably concentrated. If the sample isn't concentrated, you will not get clear results. The more concentrated you can make the sample, the more clear the bands will be, because the more material will be present in each band. Okay, we're going to do the 3 amino acids, aspartic acid, glutamic acid and leucine, and we're going to be doing the same. So we're putting them on, we're going to leave them to dry and the solvent that they dissolved in to evaporate, and then we're going to repeat it, and we're making sure that we're putting it on, we're putting it in the same place, and we're not allowing the solution to run so that the 2 spots overlap. Okay, while we're waiting for that, we're going to prepare our running solvent. Okay, because once again we're going to run it in the same way as we ran our paper chromatography. Okay, we're going to put it into a lidded beaker with a solvent. We're using the same solvent, which is butanol, ethanoic acid and water, because we're trying to move exactly the same material. So we're moving the same material, so same solvent needed, just on a media that is more precise in how we're going to separate things. Again, it's important to remember that we must keep our solvent level below the level of our line and our spots. So we've done a line at 10 mil, so we need approximately 5 mil of our solvent in the bottom of the tank. Okay? It does not take an enormous amount of solvent. It's also important that because it's a flammable solvent that will evaporate in the room, that we keep it lidded. If we don't keep it lidded, all our solvent will evaporate. So instead of it being able to run up the whole length of the plate, it will get part way up, and by the time it's got part way up, it evaporates off. And then you instead of having a moving solvent front, it kind of gets stuck. So I'm just going to keep spotting these. As we say, each time we're doing this, we're just literally building up how much material we have on the plate to run. And this is vital, because if we don't have enough, literally, you will get no results. Okay, so I'm going to keep doing that. When I've finished that, using my fingers very carefully, holding only the edge, I'm then going to place it into the tank and place the lid back on, making sure that the level does not come up to the line and therefore impede and therefore cause our samples to flow out into the solvent rather than up the plate. Alright, so you're going to join us back for part 3 when we've ran these, and we're going to show you how we're going to develop them using ninhydrin.